Okay, KI4DBK here with a spectrum display. Of course, this is the sweep on channel 1 or channel X. We're running in XY mode. And my question is, can you spot the carrier in this picture? Probably not. For one thing, my test jig is rather poor. I ran out of BNC test jumpers, test leads, so I'm going to have to get some high quality. Now that I'm getting into some more fun with some better equipment, it's going to be time to get some better cables. Like I've got these SO239 to BNC males. Probably poor practice. You know, I've got insertion loss here. Doesn't really matter if we're just playing around. But then I've got this. Looks like a nice cable, but then over here you see that it's just a clip lead. I actually need to keep that away from the grounded chassis. That could introduce problems. You may be able to see the carrier better now. And maybe not. It looks really bright in my view screen, but I don't know if that's realistic to what you're seeing. Okay, I'm actually seeing the carrier now. Now it's coming out of my Hewlett-Packard test oscillator, and it's being on the attenuator. It's outputting somewhere around 100 millivolts, tenth of a volt, give or take, and it can be fine-tuned with the vernier. The amplitude can be fine-tuned, but we're not going to worry about it at this point. Now I'm going to switch it to 0.3 of a volt, and we'll watch the spectrum analyzer. Let me go ahead and cut off channel 1. Don't need it. Maybe I can position this better for us. I could rotate. I could use trace rotation, but I'm not going to at this point, simply because I don't want to. I'm not sure if the distortion is due to a declining battery voltage or my new piece of equipment that's currently under test. But before I talk anymore over this, let's go ahead and perform the test. The carrier is hard to see, but you can see it. Hold on, let me, there we go, that's better. Get it out from under that graticule. And go ahead and kick it up to 0.3. I'm sure you can see the carrier. Let me play with the intensity. That might be better. It's better on my end. But I think this camera handles intensity better than the viewer shows. Now let's go ahead and jump on up to 1 volt. I have the attenuator on the Tektronix set to 10 dBs of RF attenuation, and then 10 decibels, and we've got a 75 ohm input, unlike the one Alan has, I noticed. Also, I was curious about the video filter. Go ahead and switch that in, see what. Oh, nice, interesting, very interesting. So that might be useful depending on what you're hunting for or what you're troubleshooting. But I kind of worry about putting too much of a signal, and I've just heard so many horror stories about people blowing up spectrum analyzers. And, you know, of course, I've got some unshielded junk going on here. Hold on, let me grab my pointer. Stand by. Alright. Second time I've done this in a video, but that's okay. So, what I was saying, yeah, the video filter, let's go ahead and take that out, because I like seeing the noise floor in a spectrum analyzer. So let's change the span. Okay, you can still see the carrier. Ah, nice, nice. So this is a great, and here as we turn, the outer knob is for the span. Let's see. Or I'm sorry. Whoa. The outer knob is for the span, and the inner knob would be megahertz per division, I believe. So. Yeah, I believe I'll leave this attenuator on, and I'm going to go ahead and switch to a full volt. Get a nice clean carrier signal. So according to the center frequency, okay, and once again I need another cable. I'll probably do this again. I don't know if I'll make a video or not, but the next time I do this, I'm going to have multiple test leads, BNC test jumpers. I'm going to have several T's. I'm going to tee this out to the frequency counter so that I will be able to verify that the center frequency on this Tektronix 1401 is close, or hopefully somewhere near the carrier displayed on the HP. But one drawback of using old equipment like this is, I know for a fact that the HP dial is off, so it's really not something that can be used in the lab unless you have a frequency counter like this one, or even like this one down here in line with it, with the frequency under test. But once you have a frequency counter that you can trust, then this test oscillator is beautiful. So yeah, I don't really feel comfortable messing around too much with any more voltage at this point until I've number one, tracked down and read the manual to this analyzer, and also gained more experience with it, using it rather. So anyway, this has been a relatively successful test, and I can't wait to have more fun with this in the future. Now I'm turning the knob on the HP as far as I'm varying the frequency in a coarse manner. So looks like we have a relatively nice range here, but still I would like to play around with the display and get a better display, and I will do that, and I may make future videos involving that. So this was an extremely live video, so if you don't like talking and rambling and experimenting during the videos, then I'm sure you can find other sites, but you're not going to find that here.